inaugural CCEW OSSM Summer Internship Program final presentation. I am Valerie Myers-Christensen. I am the Director of Programs at CCEW. And I want to thank a few people for being here today, especially Daniel Poland. He was the original Executive Director of CCEW and is now the University Vice President for Strategic Planning and Economic Development. All of the OSSM faculty who made their way down here to join us today, the OSSM and CCEW alumni who are here, and in addition, the parents who trusted us with their children for the past month. We really appreciate all that you have done. You have raised amazing children, and we really enjoyed being around them this past month. So what CCEW is functionally, it's a technology commercialization internship program. However, as a product of the program, I can say that it is a transformational experience that develops aspirations and excellence to the youth of the state and the school, really. So when we designed the OSSM CCEW program, what we wanted to do was give these students a hands-on experience in technology commercialization and entrepreneurship, and hopefully give them just a taste of that aspiration that so many of our students come away with. So we really could not have done it without all of the partners at OSSM, including Dr. Manning, who helped us handpick our students, and also Jeff Simpson, who is an alumni of OSSM and introduced CCEW to the school. And I would especially like to thank Ms. Samantha Toth. She is a graduate fellow at CCEW, and she figured out how to take what is normally a semester-long program focused on college students working on one technology and fit it into 16 days for high school students working on 2 technologies. So it is a huge testament to not only her, but also the skill level of these students and just the brilliance that they have. So what we asked them to do was really focused around 3 things. We asked them to give the university a commercialization recommendation. We worked with them to develop them professionally, and we also asked them to have fun while doing it. So they did so much over the past 4 weeks. They met with the university's executive director for technology development and learned about intellectual property and what it means to the university and to startup businesses. They worked with the tech managers for each of their technologies to figure out, just the ins and outs of those technologies. They interviewed top OU researchers, the vice president for global sales at a radar firm, and also the president at a medical devices consulting firm. They toured the National Weather Center and got to see radar labs in action. They spent countless hours researching, not only in our offices, but also at home whenever the workday was over. I am sure that they did not leave our offices and go lay out by the pool or anything like that. So, but professionally, they had some really cool opportunities that I wish I had had when I was in high school. Sam actually made it a personal priority of hers to find out what each of them is potentially interested in studying whenever they go to college, and set up meetings with faculty members in those areas of interest for them. They went to the Oklahoma City Greater Grads, they went to the Oklahoma Venture Forum luncheon, they had pizza parties with the staff, they built towers out of cups and straws so that we could test their engineering prowess before they started. But ultimately, we had a blast working with them, and I hope they had a blast, but ultimately I think you'll see the quality of work that they can do in such a short period of time. So with that, I'd like to hand it over to the team and let them introduce themselves and go through their presentations.
I'm David Ramsey. I'm also a senior at OSSM, and I'm from Oklahoma.
I'm Nathan Gaja. I'm a senior at OSSM, and I'm from Tulsa.
My name is Ronan Morris. I'm also senior from OSSM, and I'm from New Orleans.
Okay, this was our first project that we worked on, and we talked to Dr. Palmer, who is a professor at OU, and his team worked on developing a mobile weather X-band radar that is small mobile X-band radars. In the past, if you wanted to buy a mobile X-band radar, you probably wouldn't be able to due to the high price point. But with his innovative technology and software, he has developed a new market and has assisted the National Weather Service with their data coverage. Now, more on the problem. The weather information that you receive on the television or online or on your phone app is provided by the National Weather Service. They're a division of NOAA, the National Oceanic and Atmospheric Administration. The network of the National Weather Service has 140 NextRad radars. They cover up to 120 kilometers, and they're usually priced between $1 million and $10 million. But as you go towards the outer range of their coverage, the data becomes less quality, and there's a lack of accuracy and precision. This can also be attributed to the geography of the Earth. Due to the Earth's curvature and the fact that there are hills and mountains and valleys, the radar might not be able to retrieve data from, say, behind the mountain or in the valley. But when there are people living in the valley and behind the mountain, they need that weather data. And so here's David to talk about the solution.
Okay, the SDR-100X is a specific radar made for this particular problem. And in just the first couple of points, you can easily see that because of its lack of weight and production costs, it provides an excellent solution to the issue of creating a network of radars to fill in these gaps. Additionally, some innovative algorithms were developed alongside this radar and are implemented in it that give it a very good boost in data quality and the accuracy and just like the general use of this radar. It can also be deployed virtually anywhere, which makes it perfect for the application that they set out. Here's Ronald with the technical.
Okay, let me give you a little bit more of an in-depth description of the radar itself. The SDR-100X radar design enhances ease of use. Whenever the inventors were planning on making this radar, they wanted it to have 3 different qualities in specific. The first one was pulse compression. Pulse compression is basically you have the radar and you send out a first wave of pulse. These pulses are long in length, and short in width. It sends those out and sends a secondary pulse of shorter length waves. Then they both come back and reach the radar at about the same time. In regular pulse compression, it doesn't have that first wave. It doesn't have the first wave. Whenever you get the information back with just the first wave, then it takes the pulses and it compresses them into a single pixel, making the data quality of the map very good. The problem with this is that it leaves a big hole in the middle of the map. Therefore, it sends a second pulse to retrieve the information from that hole. And so now you have a nice, pretty picture. The second innovation was the up-down converter. The up-down converter basically converts different frequencies to what you need. So say you're receiving information at 300 megahertz, but you need 500 megahertz information in order to do what you need with the map. Then it'll convert it for you. The third thing that they inputted was a solid-state amplifier. A solid-state amplifier, basically solid-state just means that all the information that is received in an enclosed material. So you can think of a microchip. The electrons that transfer through it are in a specific enclosed path at all times. This differs from, say, a vacuum, where the electrons just float freely. Now you may be thinking, what is the importance of these? Like I said before, pulse compression improves the data quality of the radar. The up-down converter, its innovation is its decrease in size. Usually, the up-down converter is about this big, but they managed to put it down to where it's only about this big. And the solid-state amplifier decreases the price. Usually the overall cost of a radar, like 30 to 40% of it, goes to like the solid-state amplifier. Its decrease in size, as well as it being solid-state, decreases the overall cost of the radar. It also increases the reliability because you don't lose information through the electrons that are floating freely, some of them escape. In this case, it's not the case. Now, Nathan will tell you more about the market.
Okay, basically we are targeting the U.S. government with these radars, more specifically the National Weather Service. Now, although most of the Earth is covered with radar coverage, there's still 580,000 square kilometers that are not covered, and that gives us the opportunity to employ 70 radars. Each would be sold for $500,000, and that would give us a potential market of $35 million. And here's the line.
Now let's talk about our competitors. Our radar is mobile, just like our direct competitor, a radar from EWR. However, their range is 180 kilometers versus our 50 kilometers. On the other hand, our data quality is significantly better than theirs, and ours has a 300,000 price difference. Compared to a traditional X-band radar, which the price point is around $1 million, which isn't mobile and requires a large tower and constant maintenance. The coverage of the traditional X-band radar is larger than ours, but our size difference is what sets us apart. And now we're going to talk about the business model.
Okay, I'm going to give you a briefing on EEC. EEC is Electronics Enterprise Corporation. They are the world leader in radar sales, basically. And their annual sales range from $15 to $30 million. And OU is working with SDR, and they're currently manufacturing the parts for our radar. OU has a licensing agreement through EEC. They in turn will sell to the National Weather Service. Then EEC will be paid for that, and then OU will receive a royalty fee for their sales. And here's David with the recommendation.
After the 4 weeks that we spent working on this, we came to the conclusion that we want to recommend OU and encourage EDC to pursue additional markets outside of the National Weather Service. And some of these, such as the oil rigs, which is our top alternative market, may not necessarily be represented by their total number as far as our consumer base is. They have 48 rigs on the Gulf, but some of those, if they buy our radars, may be able to overlap coverage and thus not need one per station. And perhaps they already have their own weather coverage, but a good deal of them could use it. Wind farms can utilize this radar specifically because it provides wind information, velocity, direction, that sort of thing. It provides a valuable statistic whenever they are regulating their farms. Now, airports are by far our largest total market, and they are also by far our largest segmented market. We cannot access all 12,000 of the airports, but even though a lot of the larger airports already have their own solutions, and a lot of smaller ones can't necessarily afford to buy a radar outright. There are some in between, small percentage, that can afford this radar and do need it. Even a small percentage of 12,000 will generate a lot of revenue. We investigated some other markets, like amusement parks and sporting events, and it turns out this market doesn't really need it. They're more focused on information such as light than actual weather data, where storms are in the world. Private weather stations, on the other hand, can use it, but generally they can't afford it. Private weather stations could benefit from local coverage that's under their direct control instead of having to rely on outside sources for their weather data. So that kind of leads us to why we gave our final recommendation, which is developing a leasing model with EDC, which will allow us to access those markets that can't directly afford to buy a radar, or maybe only need it in a certain period of time. If we can get this market, we can generate a lot of extra revenue. Thank you very much. Do you have any questions? markets, are those domestic markets or international markets? And if they're domestic markets, how much time would you think about the opportunity outside of the U.S.? Maybe in geographies that don't have sufficient current coverage even with current generation technology. I think actually outside of the U.S. is one of the best markets that we can have, but it will take a while to get there, to build up enough capital base, be able to reach those sectors. Even with things like that we have listed, like oil rigs, other countries owning their own oil rigs could use this. There are even countries, governments could use it to cover it, but it's not something that is going to be in the immediate future, as far as we can tell for the market.
So those numbers represent domestic areas?
Yes, yes.
In your, in looking at your competitors, the one hard to quantify factor it seems there is the difference in the data quality, because you've got ranges in dollars that are easy to compare. You have any thoughts on how you might be able to quantify what benefits you get so that you could try to figure out how competitive are you really, and is the additional data accuracy really a good enough distinguisher that you might be able to penetrate the market of your competitor, not just be someone else in the market for you?
Well, yeah, actually we can. There's what Ronald was talking about earlier, is sending out the second pulse to gather the data that is in that gap. That is an innovative use. They don't use any new hardware, but the software that they used in order to do that is new. It's something that they've developed alongside of this radar, and no other radar has it, including EWR, who's going to have those sorts of gaps pretty often. And additionally, as far as penetrating their market, they're contracted right now with the military and NATO. Perhaps whenever that contract is up, it might be a market we want to explore, probably previously, so that the military or NATO has their eye on us before their contract is up. But again, it's not something that's going to be happening very soon.
When conducting your market research, did you actually talk to any companies in these particular markets, and was there anyone who you would consider a ready-to-buy customer?
We didn't find any that were ready to buy customers. We did talk to a couple of people, just trying to test the waters, see if they actually needed it. We talked to people in airports, which is how we came to the conclusion that there was a small percentage that would work there. We had somebody, I can't remember the gentleman's name, but he has a very close friend, a brother, in fact, that is a meteorologist on an oil rig that they have. He said that they have a need for radars out there. So, yeah.
How do you think back to the range issue between you and your competitor, how do you think that range issue fits into your usage in the other markets? Is the 50-kilometer range sufficient for all of those, or are there places where some of those uses might need the extended range and might, for example, have to have multiple devices if they were limited? How does that range affect the market?
Well, if we're talking about the specific market of the military, do you?
Well, in any of these, like in these alternative uses, how would that factor of what seems to be a limitation of the 50-kilometer range, how do you think that would affect those markets?
Well, with our radar, the 50 kilometers does cover a shorter range, but the data quality is far better. So even if it was 180 kilometers, their data might be kind of iffy towards the edges. So maybe that would make up for the range difference.
I think a price difference is also assumed here. That for almost equivalent price of one of their radars, you can buy 2 of our radars, providing not quite, but a similar amount of range and much better data quality. And that's the idea of this radar in general for places that need coverage and not just a small area. It is to create a network.
Thank you guys so much. That was their first presentation, so we're going to move on to the second presentation. But they did a great job and had a lot of fun experiences working with radars and the Weather Center and seeing the impact that can have not only on Oklahoma, but
Okay, the second device, the second project that we got the opportunity to research this month was a wireless coexistence testing environment. Now, the wireless interference poses a threat to anyone who uses a wireless medical device. OU has developed a novel software-based testing process which evaluates the interference between wireless devices and wireless systems. This $3.6 million market is unexplored. We would be the first ones to go through it. And it has accessibility due to pending FDA regulations. With this test, we could prevent many unnecessary injuries. Now, to assess the problem further, I will hand it over to Dave.
All right, I'm going to explain a little bit more thoroughly what the problem is. We start out with a medical device, and a wireless medical device with its receiver. The receiver can be anything from a remote to a box that receives data. The idea is, though, that these two, the medical device and its receiver, are supposed to communicate exclusively. But whenever we introduce a third wireless system, such as an internet router, then this may not be the case. Disruption can occur frequently, actually. And whenever it does, there are two things that can happen. The first is that the wireless device, the wireless medical device, can stop operating completely. The second is that it can just malfunction and start acting erratically. Now, whenever that happens, we have actually a specific example of this happening. A gentleman was walking into a closet with an insulin device, and he had a control box for that insulin device on his hip. And as he was walking into it, the control box started receiving feedback from a remote from someone else in the closet. And the control box overrode its current programming and started dumping insulin into his bloodstream. He eventually went into a coma. The problem being is that whenever they were questioned about it by the FDA later, who found out about it, is discovered that many times manufacturers hide these results, bury them under paperwork, try to forget about them and act like it's not a problem. So here's Elaine now with the solution.
Dr. Afai and his team have developed a testing process that involved innovative software and a novel way of placing the different medical devices. The testing process is software-based, and the software measures the data interference and reports back so you can easily infer and fix the problem and determine what the actual problem is. Also, Dr. Afai has been working hand in hand with the FDA, who not only regulates food and drugs, but medical devices, in order to create a medical device that sells in the market. It must go through the FDA pathway. And Dr. Afai has been working with the FDA to develop this push for regulation in wireless medical device interference. Now, David's going to talk more about the technical specifications.
I'm going to show you a little bit more about how specifically this test works. It also might be a quick side note to point out the testing devices used. This is an entirely software-based innovation. The testing devices used are already in testing facilities, including manufacturers and third-party labs. Now, we introduce a testing device in an environment that is as closely resembling the real world as possible. It's receiving information from both the medical device and its wireless receiver counterpart. Now, it receives the type of data it receives is the kind that directly states how much is being received as opposed to how much is being sent by both parties. So there's a little bit more to it than just looking it up and saying, okay, here's some data. There are actual physical parameters for it. Firstly, the wireless device and the wireless medical device and the receiver are placed as far apart as possible. This is to ensure that this is a worst-case scenario, and that whenever this goes out into the market, it's been tested under the most extreme conditions possible. So the wireless router itself is placed as close to as possible, usually around 1 meter, within either one of these devices, both. And the interaction between that wireless router and those two devices is measured by the testing devices, who then determine what kind of factors play into why there's interference, be it frequency or power levels, or maybe just a time situation where one is transmitting at the same time as the other, and that needs to stop. So here's here with the competition.
Okay, so you may be wondering who our competitors are. Well, this product actually uncovers a new niche that is similar to, but not EMC testing. They're not the same thing, but for the sake of an example, we'll include it. Now, let me define the two differences. EMC testing, or electromagnetic compatibility, basically tests to see if it outputs more electromagnetic energy than necessary, and if what it does output will interfere with other devices. While wireless coexistence is a device's ability to function on the same radio frequency bands as other devices. Now let me give you an example. Say EMC is an angry kid. So if an angry kid is being more violent or outputting extra electromagnetic energy, then they may interfere with the other one, even causing them to break down and not function. While, let's say wireless coexistence is in a classroom setting, one device or a child tries to communicate with the teacher, but the bully in the back starts interrupting him, and neither one can get their point across. Now we'll be comparing these two products with two metrics, output and FDA requirement. So the output for the EMC is basically a yes-no test. Yes, it interferes, or no, it doesn't interfere. While wireless coexistence actually tells you how it interferes by testing power, frequency, and time. After it tells you which one causes a problem, you can thus adjust accordingly to fix it. The other is FDA requirement. EMC testing is not required by the FDA, but instead it's used as a differentiator. So say one company tests for EMC, they can say, hey, we got this approved, so we're better than our competitors, so you should buy our product. While wireless coexistence may actually become a requirement by the FDA. Like Elaine said, Dr. Rafai is working hand in hand with the FDA in order to ensure that this problem is solved. Now I will go to Nathan, who will talk about the market.
Okay, now the question is, who wants to buy this technology, right? I mean, okay, we're talking about medical manufacturers that have pacemakers, and if any of them malfunction, the liability is solely on the manufacturer themselves. Currently, medical manufacturers spend $20 billion annually on research and development, which is 20% of their sales. Currently, there are 1,800 medical device manufacturers throughout the United States, and we would be selling our product on a software license